See these animations. How do you think these have been made? All these animations look pretty complex and different. But what if I tell you the logic behind all of these is the same and not different? Let us start by understanding what a scientific model is. You step outside your house and see a lot of things going on. However complex or simple a thing, there is something driving it. For example, there is rain, which has been explained using the water cycle. Then there is day and night happening, which has been explained using the Earth's rotation. Not only physical phenomena, but even social processes. For example, a candidate winning an election with a majority, which itself is a very complex process involving a lot of things that decides the outcome. So to answer the question of what a model is, we can say that it is trying to understand a process completely, however simple or complex it is. We try to understand all the variables or inputs in a process and then what leads to the outcome from the starting point. There are some rules or logic playing in between the inputs and the outcomes. Understanding these rules or logic is what we call modeling. The importance of modeling is not hidden in today's world. It is only because humans tried to figure out what those white diamonds in the black sky are that we today have progressed a lot in the space field. It has led to us sending satellites into orbit, knowing the Earth is not flat, which some still believe in, and exploring the moon and whatnot. Not only in the outside world, modeling is very useful and respected for knowing about our inner self. It takes the name of retrospection or spirituality there. Modeling helps to understand a process completely. It gives us the power to change the outputs as desired by making changes in the process. The modeling process is generally done over time. It is not that we see a process and can tell that these are the variables, this is how it works, and that is why the output. For simple processes, it is comparatively easy. For example, you can tell if a child is crying if you snatch a toy from him, that he wants the toy. As simple as that. But trying to understand why an earthquake comes or how a human would react to different scenarios is not that easy. For complex processes, we start with a basic model, which at that point of time fails to explain a good amount of it. Over time, exceptions are found based on which the models are improved and condensed. Once a process is known quite thoroughly, it can be made immense use of for humanity and any such use. There is an intuitive notion that complex processes have something complex going on. That is, the process is happening because of a lot of independent things going on and is not based on very simple rules. That is why generally complex processes are broken down and then we try to understand parts of it. This makes small models which explain parts of the process. One good example of this would be that before gravity was discovered, people had a number of different reasons for different phenomena related to objects. The Greeks used to say that the planets and stars were part of the god's realm and followed a natural motion. It is with time that exceptions were found, the models were improved, and then we currently have the gravitational model, which explains almost everything we see on Earth. But who knows, it might be generalized in an even better way if something we see doesn't hold true for the current model. One thing we can say is that over time, models get better by generalizing. The reasons become simpler and try to explain a vast amount of the process. And this is what takes us to the game of life model developed by the Cambridge mathematician John Conway. Let us try to understand what this model is about and what are the conclusions made from the observations. So as we said, a model tries to explain the logic of what made the inputs change into an outcome. In the game of life theory, the input is a square cell. The cell can be alive or dead. Black cells mean it is alive and white means it is dead. We define some logic or rules for the cells in this hypothetical model. Here they are. The first rule is, if the cell is alive, then it stays alive if it has either 2 or 3 live neighbors. The second rule states, if the cell is dead, then it springs to life only in the case that it has 3 live neighbors. That's it. Those are the rules. It is kind of like a cell needs the right amount of neighbors to be alive. It stays alive if the neighbor count is balanced, in this case 2 or 3. If it gets overpopulated, it dies. If a dead cell comes in contact with three neighbors, it can come back to life, kind of through reproduction. Now comes the mind-blowing fact. These two simple rules can create all sorts of complex outcomes you can ever imagine, including the ones that you saw in the beginning of the video. Enjoy seeing some more awesome animations. So, what is the conclusion from the game of life theory? The first thing that we can learn from this is that not everything that seems complex in the first look has complex rules driving it. It can be that very simple logic and reasons can create what looks like complex and unexplainable events at the first glance. We can say that everything that seems very complex has something very simple going on behind it. We often see this too in the real world. However large or complex the scale of war be, it can stem from the simple ego or hatred from one person. Lakhs of people coming out to support a cause can have something very simple behind it, be it the real connection to the cause or money. The computers that we today know as the most complex machines have zeros and ones going on in the backend. The seemingly unexplainable fire coming out of nowhere from the ground was because of the natural gas coming out. Personal things, like why you are not able to succeed, can have a very simple cause of your fear of losing behind it. We can try to use all the complex reasons to understand, but over time it will fail. Hope, now you would not try to understand everything from a very complex viewpoint, but rather have a straightforward approach, trying to find out what is really going on at the root. It often is the case that complex reasons come out of a very superficial analysis of an event. If you spend enough time and energy on something, life will reveal the most beautiful but simple secrets. That is why physicist John Archibald Wheeler in 1989 coined the phrase "it from bit." And this three-word sentence probably captures everything. It from bit symbolizes the idea that every item of the physical world has at a very deep bottom, in most instances, an immaterial source and explanation. That what we call reality arises in the last analysis from the posing of yes-no questions and the registering of equipment evoked responses. In short, that all things physical are information theoretic in origin, and this is a participatory universe. But remember, however simple the bit be, you will require a lot of effort to reach to that bit.